What is the fifth harmonic of a 45 centimeter long pan? Oh no, this is going to force us to generalize. Okay, let's figure this out. This is tough. Okay, we can do it though. Okay, so the fundamental is just the air kind of goes bouncing in and out, right? So this has got 1/4 wavelength, right? The next one is like this. This one has 1, 2, 3/4 wavelengths. All right, let's draw the next one. All I'm trying to do is just come up with a rule. I'm not really going to draw 5 of these because I just don't have that much skill. Okay, let's come up with a general rule. And this one, of course, is 1, 2, 3, 4, 5/4 wavelengths. Okay, so the next one's going to be 7/4 wavelengths, and the next one after that, the one we're interested in, is going to be 9/4 wavelengths. I don't have to draw it. I know that it'll be that. It follows the same pattern. So 1, 3, 5, 7, 9. Okay, so if the fundamental is 180 hertz, let's figure this out. Okay, I'll show you a couple ways to do this, but the first way I want to do it is just let's just use physics. Okay, so the fifth harmonic, the fundamental is 180 hertz. So let's take this guy here. Okay, 1/4. I'm going to figure out the wave speed. So 1/4 wavelength is 0.45 meters. So the wavelength is 4 times that. So 4 times 0.45 is 1.8. Okay, so that's our wavelength, right? We know that the fundamental is 180 hertz. Okay. So the wave speed in this pipe, which isn't going to change, all these have the same wave speed, okay, is going to be frequency times wavelength, right? So it's going to be 180 times 1.8. Dyslexics beware. So this is 324 meters per second. So that's the speed of the waves, right? Okay. So for that fifth harmonic, we can do the same thing, right? Let's figure out the new wavelength. So 9/4 wavelengths is 0.45 meters, right? So I'm going to go 0.45 times 4 divided by 9. The wavelength, wow, that's cool. That's 0.2. 0 meters, right? So now I can find the frequency. The frequency is going to be the velocity, which we figured out right there, divided by the wavelength. So it's going to be 324 divided by 0.2. Divided by 0.2. And I get, of course, 1620 hertz. Okay. Now, what's the easier way to do this? With this general rule, this thing goes 1 times, 3 times, 5 times, 7 times, 9 times, right? So 1, 2, 3, 4, 5. It's just simply going to be 9 times the fundamental frequency. So 9 times 180, okay, is 1620. Okay, but you got to know that. You kind of got to memorize that. That's a whole lot easier, right? Okay. Just remember, if it's a pan pipe, it's 1, 3, 5, 7, 9, 11, etc., etc. If it is both ends open or both ends fixed, it's 1, 2, 3, 4, 5, 6, 7, etc. It doesn't skip the even harmonics or even multiples of the fundamental. Okay.